Okay, in this video we're going to work through exam 1, and I'll talk through all of the problems as we go and explain them. So in this first problem we have f of x equals x squared minus 3 and g of x equals 2x minus 1. And we want to find these four things for f and g. So we'll start with f of minus 3 minus g of minus 3. So this means plug in negative 3 for x in f, so negative 3 squared minus 3, that would be f of negative 3, minus g of negative 3 means that becomes a negative 3 right there. The most common mistake would be to write that. We're actually subtracting the entire function g, so you need extra parentheses right there. And then we just compute out this number, so negative 3 squared is 9, minus 3 minus, inside these parentheses we'll have negative 6 minus 1, which is negative 7. So 9 minus 3 is 6, and then the minus negative 7 becomes plus 7, or 13. On part B, we have f times g, so we're going to multiply them. So f of x is equal to x squared minus 3. G is equal to 2x minus 1. And I would go ahead and FOIL all that out. So foiling, we get 2x cubed. X squared times negative 1 is minus x squared. Negative 3 times 2x is negative 6x. And negative 3 times negative 1 is positive 3. There are no like terms here, so nothing else simplifies. And since it's not entirely clear, I would accept either of those answers because it wasn't necessarily specified that you had to FOIL it out. Okay, then f of g of 4, we're going to work this from the inside out. And start by finding g of 4. So g of 4 means 2 times 4, which is 8, minus 1, or 7. G of 4 is 7. Then we'll find f of 7. That part is 7 there. So f of 7 is 7 squared minus 3. That would be 49 minus 3, or 46. And then the last one is g of f of x. So they're backwards. They're switched. And we're not plugging in a number for x here. Instead, it's just x. So we're going to start with g of, from the inside out, let's replace f of x by what it's equal to, which is x squared minus 3. That part is the f of x. Oops, this is supposed to be a 3. X squared minus 3. So then, if we're finding g of this quantity, we're going to replace this x right here in the function definition for g by x squared minus 3. So we'll have 2 times the x squared minus 3 minus 1, which becomes 2x squared minus 6 minus 1, which would be 2x squared. Negative 6 minus 1 is negative 7. You see, fully simplified for part D. Okay, then in number 2, we're going to work with this parabola. Y equals x squared minus 5. It should say sketch an accurate graph, a little typo there. So you get to sketch your own scale here and everything, but it's not entirely a difficult graph. You could plug in a couple points, or you could use your knowledge of shifting functions. There's a number of different ways you could work this. You could look at it on your calculator. The important parts are that it's the same shape as the graph of x squared, so it's a parabola that opens upwards, but it's shifted down 5 units. So its y-intercept is going to be down here at negative 5. Now its x-intercept would be what you get if you replaced the y by 0. So for the x-intercept, those occur where 0 equals x squared minus 5. If we solve this for x, we're going to get 5 equals x squared, where x equals plus or minus root 5. So we need a quick approximation to the square root of 5. It doesn't have to be all that good. Technically, square root of 4 is 2, square root of 9 is 3. So it's somewhere between 2 and 3, I can tell you that. Okay, 2.2 roughly. Good enough for a graph. Plus or minus there, plus or minus 2. So our parabola is going to look something like this. It'll start there, and then we need to take it out. 1, 2, 3, 1, 2, 3. And you could get other points as well. I'm just trying to do about plus or minus 2.2. As long as you have the basic shape correct, something like that would be fine. So its domain, that's the set of all of the x's that you can plug in. In this one, you can plug in any x and you'll get a y. So its domain is all real numbers, or negative infinity to infinity. Its range, that's all of the y's that are covered. If you look at this, the arrows go up forever. Once you hit -5 right there, anything above -5 is covered by the graph, but anything below -5, there's no point below -5 down here. So the lowest y value you ever hit is -5, and then on up from there. So its domain would be from -5 inclusive, so I'll put the brackets to include -5, on up to infinity. And is it a function? Well, one way to ask that is, does it pass the vertical line test? If you imagine a vertical line here scanning across the function. In fact, I think I can try to do this. There we go. So if you drag it along, I'm only touching one point at a time, so it is a function. That's because for each input, there's only one single output. So yes, this one is a function. And I didn't ask you to explain there, although you could have if you wanted to. Okay, number 3, a company manufactures and sells books. So some of their equations that they have figured out that help model their fixed costs and whatnot are, if they let X be the number of books sold each day, then the selling price for each book should be determined by this. The price is a function of the number of books they sell, which is this. Their daily fixed costs for running their business are $3.20, and their daily variable costs are 2 times the number of books that they sell. So we're going to find all the following functions here. Revenue, and I explained it to you, that's the product of the number of books sold and their selling price. Well, the number of books sold, that's X, and their selling price is P, which is equal to 10.2 minus 0.04x. So when we multiply those together to get a revenue function, that's how much money we're bringing in, right? The number of items you sell times the price you sell them at. It would look like this. 2 minus 0.04x. Let's go ahead and expand that out. So expanding or distributing the x there would give us 10.2 times x minus 0.04 times x squared. That's a good R of x, or revenue function. C of x, this is the sum of the fixed cost and your variable cost. That's the cost of running your business. So C of x would be our, let's see, our fixed cost per day, $3.20. What's the variable cost per day? It's 2x. Profit, that's the difference between your revenue and your cost, or the money you bring in minus the money you spend. So it is R of x, revenue, minus your cost, C of x. R of x right here is 10.2 minus 0.04x squared, minus our cost function is 320 plus 2x, which I should have boxed there. Okay, and simplifying this here, then we have, I'm going to distribute that negative out, and I'm going to reorder these two terms. I'm going to start with the x squared term because that's standard, so it's negative 0.04x squared. Then this will become minus 320 and minus 2x. I'll put the minus 2x first, and then I'm going to go ahead and add the two constant terms. So 10.2 minus 320, that one I would do on a calculator. 10.2 minus 320 is negative 309.8. There, 309.8. So that would be our profit function. Profit in terms of the number of books manufactured and sold every day. Average cost, that's the average cost per book. The cost, it's the quotient of the cost to you, the manufacturer, and the number of books that you sell every day. So average cost is often denoted C bar, typical. So then it's the quotient of the cost function, which is 320 plus 2x, and the number of books that you sell each day, which is just x. And we'll come back to that average cost idea later on in this course. Actually, we'll come back to all of these examples as we go throughout the course. Okay, number 4 is about lines. Find the equation of the line through 2, 2 and 4, 1. I would first find the slope of the line that goes through those 2 points, doing y2 minus y1, 1 minus 2, over x2 minus x1 is 4 minus 2. That would give me negative 1 over 2, or negative a half, or you could put negative 0.5. So to find the equation of the line, I'm going to use point slope form, and I'm just going to go with this 2, 2 point, which is y minus the y value right there, 2, equals the slope, negative a half, times x minus this x value, 2. And you could leave it like that, or you can go ahead and solve for y if you want. I'll go ahead and solve for y because I'm going to guess that's what most of you did. So distributing that negative a half out, we'll have negative a half times x, and then negative a half times negative 2 will become positive 1. Also going to add this 2 over here to the other side. So simplifying, we'll get y equals negative a half x plus 3. So let's sketch a graph here that's somewhat accurate. I'm going to take it out far enough to include the 2 given points as well as this y-intercept here. Go 1, 2, 3, 4, 1, 2, 3. Okay, so the line goes through 2, 2 and 4, 1. So it should have a negative slope. It looks like it's going to be going down. The y-intercept is right there at 3 because of that plus 3. So you go down 1 over 2. That does match up. Down 1 over 2. Keep going to get the sketch of the graph of the line. You could keep going to get the x-intercept as well, but I didn't draw my graph big enough to do that. Okay, it's always good to label points, especially if they're kind of unclear, if you're a little bit messy. Okay, so there's a good graph of that line. In number 5, we want to find this limit. The limit is x goes to infinity of 5x minus 1 over 2x squared plus x plus 1. There's several ways you could work this. You could look at the graph, which is the least accurate way, or I should say least precise way, but you could do that. You could also make a table of values with x going to infinity. I'm going to start with that method actually. Or you could do it algebraically, which I'm going to guess few people did. So let's start with it numerically by making a table of values. If x is going to infinity, then we want to choose larger and larger values of x. So I'm going to start with 10, and then 100, and 1,000, and plug those in to the function 5x minus 1 over 2x squared plus x plus 1. I'm going to pause the video while I do that. It'll take a little bit of time. So when you compute those values on the calculator, you get roughly these numbers: 0.23, 0.024, 0.0024. It should be somewhat clear that these are approaching 0 because of the increasing number of zeros right here. Those are getting closer and closer to 0. If you do it graphically, I'm going to find a graph real quick and show it to you graphically next, and then we'll do it algebraically after that. This is just a quick Google graph. You just go to Google and type y equals and the equation here. And this comes up. And what we're interested in is the limit as x goes to infinity. So I'm going to actually drag it way out here. In fact, I'm going to zoom out a little bit as well. And you can see that these values are getting closer and closer to 0. They're just getting really, really small there. So you could zoom in at any point. And as you can see where I hover my mouse, that little dot, it's showing me the y values up here, which as I take it out further and further, you have to go out quite a ways, but it's getting closer and closer to 0. Okay, and then the last way would be algebraically. The algebraic way to find this limit is to multiply both the both the numerator and denominator by 1 divided by the highest power of x that you see, In this case, the highest power of x is right here in x squared. So you would multiply this by 1 over x squared divided by 1 over x squared. It's a fancy form of 1, so we're not actually changing the problem here. And then we'll distribute that out over the numerator and over the denominator. So when we do 5x squared, let's copy the limit first. Limit of x goes to infinity. Now 5x times 1 over x squared, it's going to simplify to 5 over x because one of your x's cancels. Then negative 1 times 1 over x squared is 1 over x squared, negative 1 over x squared. Then 2x squared over times 1 over x squared, the x squareds cancel and we just have 2. X times 1 over x squared, one of the x's cancel, we get plus 1 over x. And then 1 times 1 over x squared is 1 over x squared. Now if we take the limit as x goes to infinity of each of those terms there, as x goes to infinity, 5 divided by infinity, or 5 divided by a million is approximately 0. 1 divided by infinity squared goes to 0. All of these that have x's in the denominator just get very, very small because you're dividing by such huge numbers. The only thing that doesn't change is this 2. So this ends up approaching 0 over 2, which is 0. Ultimately, it's because the power of x in the numerator is smaller than the power of x in the denominator. So either way, whether you did it numerically, graphically, or algebraically, it just said as long as you explained or showed your work, you should have gotten 0 on that one. Next is number 6. For this function, find and simplify the difference quotient. Notice I did not ask you to take the limit as h goes to infinity. That would be how you'd find the derivative. But we didn't do that, and you didn't need to do that in this problem. So the difference quotient is f of x plus h minus f of x all divided by h. I'm actually going to start with the all divided by h. Next, f of x plus h means replace each x, so that one and that one, by x plus h. So we'll have 2 times x plus h all squared, right, so it's that part, minus the next term, 2x, which would be 2 times x plus h, plus 4. That's the f of x plus h part, minus f of x. So minus the original function with parentheses, 2x squared minus 2x plus 4. That's just the first step. Getting that is worth a couple points because if you can get that, it means you understand what's going on. And then from here, it's just arithmetic. So we're going to FOIL this out, distribute that -2, distribute this negative, and start combining like terms here. And we don't want to forget the divided by h in the bottom. So in the numerator, I'm going to do a little bit in my head and do multiple steps in one, but you can write out more if you need to. So when we FOIL this out and multiply all of the terms by 2, we should end up getting 2x squared. We would get 2xh in the middle times that 2 would become plus 4xh, and then plus 2h squared. Distributing that -2 would give us minus 2x minus 2h. And we have this plus 4 right here. It's a 4. And we'll distribute that negative to get minus 2x squared plus 2x minus 4. Now I'm going to look for things that simplify here. We have 2x squared minus 2x squared. Negative 2x plus 2x plus 4 minus 4. And that looks like it. With what we're left, we can take an h out of everything in the numerator. That's the whole idea here. That would leave us with 4x plus 2h minus 2 all over h. And now that that numerator is factored, now we can cancel those h's. So your final answer should have been 4x plus 2h minus 2. Okay. And this next problem, we have a graph here. We want to use this graph to find each of these limits. We're going to start with the limit as x approaches -2. So if you look at x equals -2 right here, on the left side of -2, the y values approach +2 right there. But on the right, so the limit from the right, those y values approach -1. So that limit is undefined or does not exist. And that is because, and I'm going to go ahead and do part D here on each of the three parts up here. So that's because the limit from the left is not equal to the limit from the right, which you could have either expressed in a sentence in words or written like this. Limit as x approaches to -2. From the left of f of x is +2, which does not equal -1, which is the limit as x approaches -2 from the right. Part B, find the limit as x approaches 0. Well, here's 0 right here. Whether you approach from the left or from the right, your y values approach 1 either way. So that limit is 1. And you could explain that basically writing what I just said, or however you want to explain that. Part C, find the limit as x approaches 3. So the difference here is there's a hole at 3, and that's to see whether you know what a limit really means. Because a limit is what the y values approach or get close to as x gets really, really close to 3. But it has nothing to do with what the value of the function actually is at 3. So the fact that there's a redefined dot down here has no impact on the limit as x approaches 3. So these y values right there are approaching 0. So that limit is equal to 0. Okay, then for part 8, same graph. For the function graphed above, is f continuous at these two values of x, 0 and 3? Why or why not in terms of the definition of continuity? So let's start with 0, x equals 0. If you look at the graph, it is continuous at 0. The function just goes along, it's the continuous dot there. Really, there's no reason to even have a dot there, it's just the way they drew it. And it just keeps going, right? You can draw it without lifting your pencil, there's no holes, no breaks, no jumps, or anything. And at 3, that's the other part, here there is a hole at 3, so that is discontinuous. If you were drawing, you'd have to lift your pencil and jump over the point 3. And it's redefined down here. Okay, so for a function to be continuous at a point, the limit at that point has to exist. The y value, which it does actually here, the limit on both of them exists, it's 1 and 0. The y value has to exist, and also they have to equal each other. So at x equals 0, it is continuous, we can say yes. And that is because the limit as x approaches 0 of f of x, okay, that limit is equal to 1, which is also equal to f of 0. So something like this would be a good explanation. At 3, no, it is not continuous because the limit as x approaches 3 of f of x is 0, which is not equal to the y value at 3, which is -1, because the y value is redefined down there. So because the limit does not equal the function value, oops, that should say +3. The function value is not continuous at 3. And number 9, the function h of t equals 10 times the square root of t gives the height in feet of a hot air balloon after t seconds. We want to find the average rate of change of t from t equals 1, or average rate of change of h, from t equals 1 to t equals 9. So that means find h of 9 minus h of 1 over 9 minus 1. That would be the average rate, if you want to label it, that's average rate of change over that time period. So h of 9 is 10 times the square root of 9. H of 1 is 10 times the square root of 1 over 8. Square root of 9 is 3 times 10 is 30 minus 10 over 8, so we get 20 over 8, which reduces to, divided both by 4, so 5 over 2, or you could write 2.5, whichever you'd like. So, and interpreting those results, what does that mean in terms of rate of change? This means that, let's see, average rate of change, that's the average speed, essentially, right? The average rate that the balloon is moving at. Speed or rate of change of the height of the balloon from 1 second after liftoff to 9 seconds after I can't make it. There we go. After liftoff is 2.5 or 5 halves. See, that would be feet per second. So that's how fast it's moving. You can probably hear in the background it has started pouring from a tropical storm that's moving in. I discovered this morning that we were going to get hit by a tropical storm, and it is coming down. Anyways, okay, so if you have any questions about that one or the interpretation, let me know. Then number 10, use derivative rules. Yay for derivative rules. They make finding derivatives so much easier. So on this first one, we're just going to use the power rule here. So f prime of t, bring this 2 down and multiply it times the 16 to get 32. T to the first minus 64. And that's it. That's all there is to that one. Derivative of negative 64t is the coefficient of t, negative 64. And the second one, part B, you could use quotient rule on each of the 3 of these, but that would be the long way. So first I would rewrite g like this, x to the minus 1 plus x to the minus 2 plus x to the minus 3, and then use the power rule on each of those. So g prime would be equal to, using the power rule, negative x to the minus 2, that's the power rule on the first term, plus negative 2 x to the minus 3 plus negative 3 x to the minus 4. And I guess it'd be a little bit cleaner to write it as negative instead of plus negative. Also, I need to plug in negative 1 here. So g prime of negative 1 is the negative of negative 1 to the minus 2. This plus negative 2 becomes minus 2 times negative 1 to the minus 3. And this becomes minus 3 times negative 1 to the minus 4. You could compute that in your calculator, or you can work it out by hand. I'm low on space here, so I'm going to come up this way. Okay, so that would be this negative. It's a lot of negatives here. And I'm going to write these each as fractions, actually. So that would be negative 1 over negative 1 squared. Negative 1, I better write it out. Negative 1 squared. That's the negative 1 to the minus 2. And this becomes minus 2 over negative 1 cubed minus 3 over negative 1 to the 4th. So negative 1 squared is 1. So the first term is just negative 1. Negative 1 cubed is negative 1. So negative 2 divided by negative 1 is positive 2. Negative 1 to the 4th is positive 1, so the last term is minus 3. So negative 1 plus 2 is 1. Minus 3 is negative 2. Lots of negatives going on there, so hopefully you were careful with your arithmetic on that one. Part C, find h prime of t. So we're going to use quotient rule on this one. So the quotient rule here, use the little mnemonic device, is low d high minus high d low over low low. So low is t minus 3. D high, derivative of the numerator, is 2, minus high, 2t minus 1. D low, derivative of t minus 3 is 1, all over low low, t minus 3 all squared. And we should simplify that up just a little bit. So in the numerator, that's 2t minus 6, distributing that out right there. And this will become minus 2t plus 1. All over t minus 3 squared. Those two t's, it looks like, cancel. And then negative 6 plus 1 is negative 5. And then the last one. This is the most challenging one, and that's why you had a whole page for it. Just because I knew it would take some work to write it all out. So can you find the second derivative of this function f at 9? There's a couple ways you could do this. One is you could use the product rule first and see what you get, which is what I'm going to do because I think that's probably what most people did. Another way would be to FOIL this out first and then differentiate, which would probably be a little bit easier. But I'm going to assume most people did not do that. So let's see. Need a little bit more space here. There we go. Okay, so using the product rule, Product rule says that f prime is the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. So the first factor is root x minus 4 times the derivative of the second factor. And I'm going to go ahead and rewrite the square root of x as x to the half, since I'm going to have to differentiate that. Plus the second factor, root x plus 3, times the derivative of the first factor, let's rewrite that root as a power of a half. So times x to the half, derivative of x to the half minus 4. Okay, so I'm going to recopy that first factor, root x minus 4. Now this derivative is power rule. So we'll bring the half down, so it's 1/2 x to the negative a half. And then the derivative of 3 is 0. So those parts correspond there. Plus root x plus 3 times this derivative, the same actually as the first derivative. Using power rule, it's a half x to the negative a half. The derivative of minus 4 is 0. Okay, before I differentiate that again, I'm going to clean this up as much as I can so that my next derivative will be a little bit easier. So I'm going to rewrite this negative a half part as a radical so I can maybe combine it with that radical. We'll see. So root x minus 4, and then the negative means that goes in the denominator. So it's times 1 over 2 times the square root of x. So negative a half power written in the denominator as a radical. And it's the same thing over here. So plus root x plus 3 times 1 over 2 root x. And it looks like if we distribute that out, some things over both those, so some things will cancel a little bit, because root x times 1 over 2 root x, those root x's completely cancel, and you're just left with 1/2. Then we have minus 4 over this. 4 divided by 2 is 2, so that'll become minus 2 over root x. And if we distribute here, root x times 1 over 2 root x, the root x's cancel, so we get plus 1/2. And then plus 3 over 2 root x. So I haven't differentiated again yet. I'm still working with the first derivative, just trying to clean it up as much as I can. I'm going to go ahead and add these two numbers here. 1/2 plus 1/2 is 1. Let's put that right there. Okay, then we have plus two terms that have x to the minus 1/2. You could get a common denominator here, which actually might be the easier way to do it. So basically what I'm going to do is undo this 4 over 2. I had simplified it to 2, but let's just leave it as 4 over 2, because then I can combine this term with this term because they have the same denominator. So negative 4 over 2 root x plus 3 over root x, we'll add those numerators. Negative 4 plus 3 is negative 1 over 2 root x. So that is, let's see, that term and that term combined to give me that term. Okay, and I can write that, I'm going to rewrite that as 1/2 x to the negative 1/2, because that's going to be easier to differentiate for the second time. So that's the first derivative. A lot of work there. Then for the second derivative, because I've simplified this so much, it should be a little bit easier. The derivative of 1 is 0. So we have negative 1/2 times, by power rule, that negative 1/2. Negative 1/2 times this power, negative 1/2. X to the power of negative 1/2 minus 1 is negative 3/2. And that's it. So let's simplify. Negative 1/2 times negative 1/2 is positive 1/4. X to the minus 3/2. If you write that as a radical, that would be 1 over 4 times the square root of x cubed. We need to find f double prime of 9. So let's plug in 9 for x now that we have the second derivative. So we get 1 over 4 times the square root of 9 cubed. There we go, that's a cube. Okay, square root of 9 is 3, so 1 over 4 times 3 cubed. That's 1 over 4 times 27. See what that is. So 4 times 27 is 108. So 1 over 108. So that's the first exam. Let me know if you have any questions over any of those problems.